Welcome to my channel. Today we are going to discuss about the objective type questions from the three types of antenna: resonant antenna, rhombic antenna, and helical antenna. So already I posted the 6 videos. Okay, so from the unit 1 and unit 2, this is a seventh one. If you want to learn those videos, means I will give the link for those videos in the description box. You can see. Okay, so we will see. The first question is: the resonant antenna has a length in multiples of lambda by 2. It's a true or false? It's a yes only. The resonant antenna, it has the length in a multiples of lambda by 2. Lambda by 2 or lambda, that is 2 into lambda by 2, 3 lambda by 2, 4 lambda by 2, and so on. So this is true. And the antenna transmits efficiently when the length is lambda by 2, lambda by 4. Okay, so the antenna, it transmits efficiently if the length is lambda by 2 and lambda by 4. Okay, then the resonant antenna is a dash: periodic antenna, traveling wave antenna, rhombic antenna. So the resonant antenna, it's a periodic antenna. Resonant antenna is a periodic antenna type. Then the voltage and current in resonant antennas are dash. Okay, so the voltage and current. So usually we are saying it as a resonant frequency, means at a resonant frequency the voltage and current is in phase. Okay, but in resonant antenna the voltage and current in resonant antenna are not in phase. Okay, not in phase. This is the important thing you should remember. Then the next one, the standing waves are produced in non-resonant antenna. So the antennas, there are two types: resonant antenna, non-resonant antenna. So here the statement is the standing wave. So already you know the standing wave, the superimposition of incident wave and reflected wave, it is called as a standing wave. So the standing waves are produced in non-resonant antenna. This is true or false? It's a false. Okay, standing waves are produced in resonant antenna only. In resonant antenna only the standing waves are produced. In non-resonant antenna, standing waves is not produced. Okay. Then the next one, the traveling waves are produced in resonant antenna. This is true or false? This is also false. Okay, the traveling waves are produced in non-resonant antenna. So you see, the standing waves are produced in resonant antenna. The traveling waves are produced in non-resonant antenna. Okay, then the next question, antenna above its critical frequency is resistive in nature, inductive in nature, capacitive, all of the above. Okay, inductive. So antenna above its critical frequency, it is in which nature, means it is inductive in nature. Then the next one, a rhombic antenna is a dash. It's a type of resonate, it's a non-resonate, both of above, none of the above. Non-resonant antenna, rhombic antenna, it's a type of non-resonant antenna. Okay, then the rhombic antenna is a dash. It's a traveling wave antenna, standing wave antenna, narrow band antenna used in low frequency band. So rhombic antenna is a traveling wave antenna. So already you know the rhombic antenna is a non-resonant antenna. So already we discussed in non-resonant antenna, the traveling waves are produced. So that's why this rhombic antenna is in the type of traveling wave antenna. Okay. So the resonant antenna is in the type of standing wave antenna. So rhombic antenna is a non-resonant, so it's a traveling wave antenna. Then the rhombic antenna is used for transmitting purpose only. It's a true or false? It's a false. Okay, rhombic antenna is not used for the transmitting purpose. It's used for both transmitting and reception purpose. The rhombic antenna is a high frequency antenna. Yes, it's a true. So rhombic antenna is a high frequency antenna. Okay, so these are the some of the thing about rhombic antenna. So from this you can just remember it. The rhombic antenna, it's a high frequency antenna and it is a non-resonant antenna. So that's why the rhombic antenna is under the classification of traveling wave antenna. Okay, and in resonant antenna, what are all the thing? In resonant antenna, standing waves are produced. In non-resonant antenna, the traveling waves are produced. Okay, and in a resonant antenna, the voltage and current are not in phase. Okay, not in phase. And the resonant antenna, it is said to be the periodic antenna. Okay, and this resonant antenna has the length is a multiple of lambda by 2. Okay, These are the some of the thing about this resonant and rhombic antenna. And the next one, tower antenna. There is a one classification, tower antenna. The tower antenna is a LF, low frequency antenna, high frequency antenna, UHF, ultra frequency antenna. So the tower antenna is a low frequency antenna. Okay. Then the next one, helical antenna. The helical antenna can be used in high frequency and very high frequency band. It's a true or false? It's a true. The helical antenna, it is used for the high frequency and very high frequency bands. Okay. And the helical antenna is used for satellite tracking. Okay. This helical antenna is mainly used for satellite tracking. In telemetry, satellite telemetry, we are using this helical antenna. It's a very important application. So why we are using this helical antenna for satellite tracking? Because of its broad bandwidth, good front to back ratio, circular polarization, high gain. So because of this circular polarization, the helical antenna is used for a satellite tracking. Then the next question, Stone invented the helical antenna. The statement is true or false? It's a false. Okay. The helical antenna was invented by John D. Cruz. Okay. So the helical antenna, it is invented by John D. Cruz. The Stone not invented the helical antenna. Okay. The next one, which kind of polarization is provided by helical antenna? Plane polarization, elliptical polarization, circular polarization. Circular polarization. The helical antenna is producing the circular polarization. So because of that, the helical antenna is used for a satellite tracking. Okay, so it's a main important thing. Then the next one, which mode of radiation occurs in a helical antenna due to smaller dimension of helix as compared to wavelength? So in helical antenna, there are two modes of radiation is that normal mode and axial mode. Okay. So which mode of radiation due to the smaller dimension of helix as compared to wavelength? So the helix dimension is very, very lesser than wavelength. At that condition, which mode of radiation is happening means that radiation, we are calling it as a normal mode. Okay, then the other one is the reverse, the dimension is somewhat greater when compared to the wavelength means that mode is called as axial mode. Okay, then the next one, the circular polarization is formed in helical antenna, Yagi-Uda antenna, parabolic dipole antenna. The circular polarization is formed in helical antenna. Okay, in Yagi-Uda, it's a unidirectional pattern. Okay, so it's a linear polarization. The circular polarization is formed in helical antenna. Then a helical antenna produces a radiation which is circular polarized, omnidirectional, both of the above, none of the above, circular polarized. So the helical antenna produces a radiation is in which one means circular polarized. Okay. Then the helix is having the geometry of dash. Okay. Straight bio, circle, cylinder, all of the above, all of the above. The helix is having the geometry, all of the above, straight via, then circular in manner and cylindrical manner. All geometry is available in a helix. Then the radiation pattern of helix in axial mode is dash. It's a bidirectional, unidirectional, four-looped, omnidirectional, unidirectional. The radiation pattern of helix in axial mode, it is a unidirectional. Okay. Similarly, the radiation pattern of helix in normal mode is bidirectional. Okay, so you just remember in helix, there are two modes there, normal mode, axial mode. In normal mode, the radiation pattern is bidirectional. In axial mode, the radiation pattern is in the unidirectional. Okay, then in normal mode of operation, the length of the helix is dash. Okay, so already we discussed in that. In normal mode of operation, the length of the helix is less than operating wavelength lambda. Okay. Similarly, in axial mode of operation, the length of the helix is equal to lambda. So in normal mode, the length is less than lambda. In axial mode, the length is equal to operating wavelength. Then the helical antenna produces circular polarization. It's a true. Okay. Then the helical antenna is mostly used in normal mode. It's a true or false? It's a false. Okay. The helical antenna is not at all used in normal mode. In axial mode only, the helical antenna, it will use for application wise. Okay. Then the helical antenna is mostly used in axial mode. Yes. Okay. The helical antenna is mostly used in axial mode. In normal mode, it is not used. Okay. Then the helical antenna is used in dash. Okay. So what are the applications of the helical antenna? Means telemetry, satellite, and probe communication. So these are all the very important application of the helical antenna because of the circular polarization. Okay. The helical antenna is used for transmitting and receiving purpose. Yes, it's a true. Okay, helical antenna is used for transmitting purpose also and receiving purpose also. Both transmitter and receiver, we are using this helical antenna. Okay, so these are all the some of the questions about the helical antenna and the resonant and non-resonant antenna. Okay, so the helical antenna, in that there are two modes of operation is there, normal mode and axial mode. The helical antenna was invented by John D. Cruz. Okay, so which type of polarization is provided in helical antenna? Means it's a circular polarization. And this helical antenna is used, which frequency band? Means high frequency and a very high frequency. This helical antenna where we are using means satellite, telemetry, and that communication, we are using the helical antenna. Okay, so main thing, it is used in a circular polarization. So depending upon the dimension of the helix, there are two mode of operation, normal mode, axial mode. Okay, in normal mode, the length of the helix is less than the wavelength lambda. Okay, in axial mode, the length of the helix is equal to lambda. Okay, then the radiation pattern in normal mode is bidirectional. The radiation pattern in axial mode is unidirectional. Okay, so these are all the some of the questions about this helical antenna. Okay, so thanks for watching my channel, and please subscribe my channel for more videos. In the next video, we will see about some of the antenna. Okay, so thank you.